Hello friends, welcome to Shiksharthi. In this video, we will discuss the maximum and minimum values of sine theta and cosec theta. So let's start. Now we all are aware of sine theta being equal to, for example, if I take a triangle like, let me take a triangle. So now this is the right angle triangle that I have taken with the vertices as A, B and C. Now this is the angle that I am taking. Let's say this angle is theta. In that case, this angle A becomes 90 degrees minus theta degrees. And then the length of the line segment AB, I am taking it as P, which is perpendicular. The length of the line segment BC, I am taking it as base, which is B. And the length of the line segment AC, I am taking it as the hypotenuse, which is H. So we know that sine theta, so we are talking about sine C. So sine C is equal to, now we know that this is perpendicular upon hypotenuse. So now we need to find out the maximum and the minimum value of sine theta that it can take. So for this, and even before we begin this, we know that perpendicular is either the smallest among the three, because we know that the hypotenuse is the largest. So we can make two cases here. To be more precise, we can make three cases. So these are the three cases that I have made. So you can say broadly these two cases are the same. So when I say broadly these two cases are the same, what am I trying to say? I am trying to say that H is not equal to P is not equal to B. And the second case that I am taking here is, I know that H definitely is not equal to P, but P is equal to B. Is the case that I am taking. Now since this sine theta trigonometric ratio has nothing to do with the base, it concerns only the numerator, which is the perpendicular, and the base, which is the hypotenuse. So for the time being, let's put it as this is a numerator upon a denominator. Yeah. So now once we have put it like this, now let us see what can we divide this fraction into. So I am taking it as now a numerator upon a denominator. So a numerator upon a denominator can be broadly divided into two parts. One is the numerator is equal to the denominator. Second is the numerator is not equal to the denominator. In this case, we are talking about the perpendicular being equal to the hypotenuse. In the second case, we are talking about the perpendicular not being equal to the hypotenuse. So we know that we can't, the three cases that we had made, in all the three cases, the perpendicular was not equal to the hypotenuse, because this cannot happen in a triangle. But then what we can do here is, the moment I take the hypotenuse, let us say this is the hinge. From here, I hold the hypotenuse from here, and then I swing it in favor of the perpendicular. So let us say this is the arm of a clock which is swinging. I mean, this is the pendulum. So now this AC swings and occupies, I mean, it becomes, let us say it supersedes AB, supersedes and covers totally. So what could be the limiting value for the hypotenuse? Could be equal to a 1, the limiting value. So I can say the limiting value here becomes equal to a 1. I mean, the best way to understand this is, I mean, just hold it from here and then swing it towards the perpendicular. It is just like saying when you're taking it towards the perpendicular, naturally this length is more. So let us say it comes somewhere here. So it will superimpose, it will superimpose on the perpendicular, which is just like saying the limiting value. So this becomes the limiting value. Okay, now when I say P is not equal to H, what am I basically talking about? I would talk about two cases. One is P is lesser than H. The other case is P is greater than H. So now P cannot be greater than H because we know in a triangle the hypotenuse is the longest side. Okay, so in that case we will have to rule out this case and we will have to only consider this case. Now we are taking this case is just like saying if I am taking the ratio P by H. Now if I take H down, this will be lesser than 1. Right? Okay. Now the next point which here is what are the different values that I can take. So from here you see that, I mean, if I were to just club both these discussions, the maximum value of P by H is equal to a 1, or it is lesser than a 1. Right? Now if I see the negative value, accordingly I can say the negative value here is P by H is equal to a -1. Another way to understand this is when will P and H be equal to each other? I mean, when I take any integer values equal or whatever. Right? Now when I say P by H is less than 1, what are the values that I can give to P and H? Let's talk about that. So when I talk about that, let us see what are the values. So one case, let's say I'll just make the cases rather than saying, though broadly what we can make the cases here is we can take both of them to be positive, both of them to be negative, one of them to be positive, the other one to be negative, and so on. So can I take P as 0 and let's say this as +1? Yes. Can I take, now keeping in mind that P should be less than H, this as -1, this as +1? Yes. Now can I take both of them as positive? So now when I am taking both of them as positive, I just need to know that P by H, the ratio should be either equal to 1 or lesser than 1. So can I take both? So can I take both as +2, +2? I can. Can I take the value of P as, let's say, +0.1 and the value of H as +0.2? Yes. And then we can talk about some negative values. So what are the negative values that I am talking about? Let us say -0.2, -0.1. These values are sufficient to tell you what? These values are sufficient to tell you that here P by H becomes equal to a 0. What is the value of P by H from here? The value of P by H from here is -1. The value of P by H from here is +1. The value of P by H here is 1/2 plus 1/2. The value of P by H from here is 2. Now when you see this, you know that now when you are saying that P by H is equal to a 2, in a certain way you are saying the perpendicular is greater than the hypotenuse. So you can't take these values. So all these values are sufficient to prove what? They are sufficient to prove that P by H will be greater than -1, it will be lesser than +1, at the same time it will be equal to also. You can just club all these cases and find out the values. Hope you understood this. Now this was in case of sine theta. Cosec is the reciprocal for this. Cosec theta we know is hypotenuse upon base. Hypotenuse upon perpendicular. So this entire discussion changes to what? Now here when I am talking about H by P, keeping in mind that H is greater than P. So again we can just take these values only that we had taken from here. So when we take these values, so let us say the first case that we have taken here is 0, +1, -1, +1, +2, +2, +1, +0.1, +0.2, and the last case, let's say -0.2 and -0.1. What is the objective? You're taking one of them as negative, the other one as positive, both of them as positive, both of them as positive, both of them as negative. So let's say if you want to take one more case wherein and this we are taking it as P comma H. So here also we are taking it as P comma H. So how much is H by P here? This is 1 0. Now 1 by 0 is not a defined format, but we will say 1 by 0 tends to infinity. At the same time, let's include one more value, which is 0 comma minus 1. Okay, so how much is H by P from here? H by P from here becomes minus 1. From here it is plus 1. H by P from here is 2. H by P from here is 1 by 2. And H by P from here is minus 1 again. H by P from here is minus 1 by 0, which becomes minus infinity. So this is plus infinity. So this I think is sufficient to give you an answer. Is this possible? Yes. This, yes. This, yes. Is this possible? Yes, because H is always greater than P. Is this possible? No. Is this possible? Yes. Is this possible? Yes. So from here you will be able to say for cosec theta, H by P takes a minimum value as plus 1 or greater than plus 1 for positive side. And for the negative side, you would say the maximum value is minus 1. So the minimum value for cosec theta when you are getting a positive trigonometric ratio is plus 1, and the maximum value for cosec theta when you are getting it as negative is minus 1. This is the best way in which we can understand, though there are other ways of understanding both, maybe with the help of derivatives, maxima, minima, with the help of graphs and so on. But in any case, the answer that we have got from here would be the same. What is the concept that I have used here? I have used the concept of fractions and numbers and some logic in it, right? If you feel that this video was really informative and knowledgeable, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you start receiving updates from us regularly. If you want us to do some videos on specific topics or difficult topics, let it be known to us so that we can do it for you. Thank you so much. Until next we meet, goodbye.